Okay, so let us start with very basic concepts about why and how of AutoCAD. So, first of all, if you were able to install AutoCAD by now, go ahead and on the very right hand side, you'll be able to sign into your account. So try to sign in always when you're working on AutoCAD in case you need to save on the cloud or in case you need to get on the help menu. This will be easier for you if you are already connected. There are tutorials and there's plenty of help. Whenever everybody's on the same page, I'll open up AutoCAD and we'll go over how to access help and tutorials. And obviously, you'll follow my um, lead on how to use AutoCAD. But let's start by the very beginning. So um, I'm sure none of you, or well, I don't know what students are part of this class, but at least I wasn't born where Commodore 64 was around, but it's very famous um, because is one of those first computers, home computers. That's the concept. It was a home computer before the um, computer, before the home computer concept existed. So laptops were not around. It was mostly everything was a huge tower built huge. I mean, I don't know if you've seen old movies, but computers used to be whole cabinets of rotating disks to save data. And that was the thing about Commodore. It was home computer, smaller, quote unquote, smaller shape, even though it's way bigger than any computer today, but it was 8-bit. So for those of you who are not familiar with bit notation with the computer science aspect of computers, um, as you know, 1 bit can only be one or zero, or zero and one, right? So if you want to save a number, I don't want to turn this into a computer science class, but there's something called ASCII files, and this is what we use. So A, B, C, all the way to Z, and 0, 1, 2, all the way to 9. Computers don't understand this, but humans do. So the ASCII notation is what we as humans understand, but a computer really only cares about zeros and ones. So somewhere here in between you have plus and minus and multiplication and division and things like percentage or numeral or pound, whatever. All those things have to be defined so that the computer can understand what to do. So for example, I don't remember any of these things and they're standards, but for example, say A is 0001. I'm making this up. And B, okay, let's do it here. A, we say 0001. B is 0010. C is 0100. D, etc. So as you can see here, you only have two options, 0 and 1, and 4 digits to accommodate. So this is 4 bits. So the bit is the 0 or 1, but how many of those you have? We have 4. Okay, so this will be 2 times 2 times 2 times 2. What is this? 64. 2 times 2, 4 times 8. Oh, sorry, 16. So 2 times 2, 4 times 2, 8 times 2, 16. Yeah, so there's 16 configurations here. So here we only have, you can only accommodate 16 letters. All right, so if you keep going to the 5th, 6th, 7th, 8th, so 8 bits is going to be 2 to the 8, and that is equal to 255. So you have 255 possibilities or commutations or options of zeros and ones, right? And in that 255, you have to accommodate all the letters in English because it originally was in English. You have so plus you have to accommodate 10 numbers from 0 to 9. You have to accommodate the parentheses, the hat, the ampersand, all those things. Okay, and let's say that's 50, just to tell you a number. Okay, so you have 255. You would think, well, 255 is plenty, but not really, because first of all, that's you already used 50 out of the 255. You already so let's say 55 things to make things easier, and those 55 are from A to Z and from 0 to 9, and all the math operators plus all the things that you need to create to communicate, like a backslash. Just look at your keyboard, all the things that I'm not even mentioning. So like exclamation points, interrogation mark, all the parentheses, brackets, all those things. Let's say you have 55. Well, so you have 200 open spaces to save things. And those are when you save, let's say when you're creating a project and you're creating a math computation, or you're creating a letter. So that's the space in RAM that you can access to save things. So just to give you a perspective, right now we're way beyond 64-bit, right? Okay, so this is billions of bits that we have just to save things. And one thing you have to remember that is probably not intuitive is that when you turn your computer on, there are things that are already saved, like your Windows operating system, your OS, has things already saved in libraries so that they can boot. So they're taking part of this operation to run. Your processor, this is the key point. Your processor has right now today has the x86 architecture. Well, all those things have things behind that are saved. And you probably have seen when you have an error or you have when you're learning C, or if you had to, a virus, sometimes you get all these weird hexadecimal things, zeros and ones and ampersands and whatever. Well, those things are saved in this x86 computer files in your programs so that they can know how to convert ASCII file into ones and zeros for the computer. So anyway, that's just a long story to tell you that in 82, so 41 years ago, it was when they started doing this home computer concept. Now, in 83, they had huge amount of sales. So I don't care. I don't know if you really care about this, but everybody started getting, every house, everywhere started to getting a computer. So brands, Commodore was a brand, but other brands showed up, such as HP, Dell, um, and they're starting to making things left and right so that you can sell the computer up until the point that they're starting to create the laptop concept. All right, so all this is just the history of how we came to have AutoCAD today, because before, these drafting tools were very basic, were something like Paint, and in this amount of space, 8 bits, you would not be able to have all the things that you have to save for your AutoCAD. Okay, so AutoCAD today is very, very complex on the amount of things that you have to save. There's gigabytes of data that you have to save just to install the software alone. So be careful when you're installing it on a computer. Make sure you have enough room for the software to be installed. All right, so you can go online and find a bunch of information about the history of computing and how CAD was a big push, a big reason why computers needed to be better, because graphics cards and processors needed to be better so that you can do all the things that we're going to be doing. In case you care about more of the history, there's two, well, there's a few players here. We have AutoCAD and SolidWorks in this chart. There's another one which is CATIA, which is used for aerospace and automotive. There's another one called Pro Engineer. It's used, it's very good, but it's not very common. It's not very easy to use, but it's very robust. The two most common ones for sure are AutoCAD and SolidWorks. Now there's another one called Onshape, which is a cloud-based. All this you have to install on your computer, which could be a pain. You have basically to get a gaming computer if you want to be doing things with a lot of parts, with huge assemblies, like a whole airplane is a huge assembly. Um, but AutoCAD is made by Autodesk, and they have a lighter version which is also cloud-based, or you can install, called Fusion 360. Actually, Autodesk has a lot of products. There's a free one just to start tinkering around, which is Tinkercad. We might have a few sessions on this because it's free and it's just easy to make things for 3D printing. But up into this is, I think this is 2020, AutoCAD versus SolidWorks. So in the area of construction, I think this is the amount of companies. I have to go to the source again. For construction, AutoCAD is by far the most used software. Autodesk has something for architecture, which is I'm forgetting right now. Revit. Yes, there's another one called Revit from Autodesk. So Autodesk has a huge suite of products. SolidWorks is not very used in construction. You can see SolidWorks is very famous though, is because it's really good with surfaces with 3D bodies. AutoCAD is better with, for sure, my take, 2D parts and drafting. Okay, it's very robust. You can do a lot of things, but when it comes to 3D, SolidWorks is made for smooth surfaces. For machinery, for our production, for manufacturing, still more. You would probably get more AutoCAD based on the source than SolidWorks. So depending on the area of what you want to work at, you'll see that Autodesk or AutoCAD is usually, you find it everywhere you go. If you have if they have SolidWorks, they probably have a few licenses of AutoCAD. And the same thing with the other way around. If you were going for AutoCAD, they probably also have a license of SolidWorks because they're around the same price, and they just have different features that people like. And also, if you know how to use one, you pick up the other one easy. Well, if you know AutoCAD, you'll pick up SolidWorks very easy. If you know SolidWorks, you probably will have to take some time to learn AutoCAD. So that's why people like AutoCAD, because it's basically one of the first computer-aided design softwares out there. So everything's really based on AutoCAD's concepts. Okay, computer hardware, they're basically almost the same. Mechanical and industrial engineering, AutoCAD is leading in amount of companies that use it, and mining and metals, also AutoCAD. So as you can see, AutoCAD is a really good tool to learn if you're going to be in the world of drafting and production in engineering and even in science. All right, so as we said, 86 from 86 up until recently, AutoCAD has been the leader of modeling software. Is used for drafting and annotations. Annotation is when you have a part and you want to have a drawing that shows the dimensions. So like, this is 5 inches and this is 10 or whatever. This is annotations. Okay, so it's very straightforward how to get those from AutoCAD. All right, in 2020, AutoCAD was still a leader in this type of thing, but SolidWorks is closing up because SolidWorks partnered up with somebody called Go Engineer, and now they have a huge vault or repository, so that when you have hundreds of drawings, you and you have a company with 40 engineers that want to access the latest drawing. If you notice, think about how we're doing AutoCAD right now. So we're installing AutoCAD in our local computer on your own machine. And let's say we're working in a company where all of us are designing a product, part of an airplane or something like that. And some of us have to get the latest part so that we can keep going with our jobs. Well, it would be pretty tough and not very productive to wait for somebody to finish it and then get a flash drive or send it by email. Well, even if the part is very large, the email portion won't work. Maybe you have internal network so you can send it through, internally. But with this vault or repository part, with a repo, anybody's connected to the vault, and then you're saving it, and that is a local cloud. It's a local cloud in your company, and the latest version will be saved as version beta, I don't know, 12 or 22, whatever. So now I can open version 22 and real time. Somebody saved it, now I see it. Version 21 is also there. So if version 21 had an issue, then I can always go to version 21 from the cloud. And you don't really have to save anything locally anymore. And you don't have to just have thousands of files on each computer. So this repo concept is very useful, and SolidWorks is really SolidWorks is not really gaining market because it's better than AutoCAD. It's just because it's making things very convenient for a lot of companies. But of course, AutoCAD noticed that, so now they're going with something similar with other companies, creating their own repo. All right, so one thing that is important, please notice that for SolidWorks, the native drawing, the native file, what does that mean? What is native file? So if you notice, if you have a Word document, the native file is some name, my file, dot docx, or PowerPoint is pptx, etc. Well, in SolidWorks is dot solidpart, SLDPRT. And Autodesk or AutoCAD Beta is .dwg, and you can use it. You can create a lighter version as .dxf. Okay. All right. So yes, as we said, this being used for many different industries. All right. So AutoCAD versus other tools. Something just again, same thing that we're mentioning. AutoCAD is a really good first tool to learn, or second tool to learn if you already know Rhino. It's just way more comprehensive, more advanced than would say Illustrator or Photoshop. This is a true CAD engineering software. All right. So in homework 1, we'll have an assignment where we have to draw or design a part with just pencil and paper. And just while you're doing that, think, how would you model it with a software? If you don't know any software, then think all the things that it would take for, for when you draw on, how would you even do that? Do you just use your mouse to draw something, or that wouldn't be very useful? Or can you call a library of parts and start joining and cutting and creating things from rectangulars, etc.? So think the process of how you model your part is very important. All right. Yeah, so the environment and documentation. Documentation is always create the annotations, and have tables and have names of who's drawing this and dates. Um, so yeah, this a drawing is always a living document because you can revise the version, you can always update it, but it should always tell whoever opens the drawing or prints the drawing who made it and the date, because then you can think of, oh well, this was probably, if it's 2022, then there was such and such product. Now in 2023 we have two versions after that. Okay, so always put the right documentation on each drawing. Um, and this is other stuff that I don't think we need to know, but so an example problem is we're gonna be using um, as one of the homeworks, we're gonna go to a job search tool such as Indeed or Google or LinkedIn or whatever, and we're gonna be looking for what type of jobs require AutoCAD and what type of jobs and what do they require. Is it electrical? Is it mechanical? Or is it um, structural, or is it architecture? So I'll give you more details about this homework when it's time for submitting the homework. Okay, so very important concept to understand. When you go ahead and open, we'll go over this again when once you have AutoCAD installed. I just want to make sure that everybody has it installed by now, and then we'll go over it when we have AutoCAD open on, we can actually go um, through the icons. But once you open it, you'll see that it's going to be either white or black. That really depends on what version you installed, but you can always change it to what from the options to black or white or gray or whatever. So that's not a big deal. The important thing to know is that you have an application button, and again we'll do everything here from AutoCAD once everybody's installed the software. So obviously here is going to be just like Word, Microsoft Word. We have save file, so all the file options. We have export. A lot of times we have to export to other software for manufacturing or further analysis. Um, and of course the save options, as I said, and also all the options. So here's where you have to set up your properties for units, your properties for how is your AutoCAD gonna look like, um, its fonts, etc. So for now, we'll just go very basic stuff, and then we'll go into details once we have AutoCAD. All right, this top part is the ribbon. This is where you're gonna have all your views, your annotations, your 2D versus 3D, layers. We'll have a whole concept of layers to go through. All right. Between above the ribbon, there's something called the quick access bar, and that's just basically to save and to print and even to export, etc. The file tab is because you can have as many files as you want, and they're gonna be here at this part. So like this is drawing number 1. The drawing course, this area here is going to be the drawing cursor. The cursor is always going to be across, and it's going to be, as long as you're on the drawing side, you're going to be able to click or drag, or you'll be able to see it. Your coordinate axis is always on the left hand side by default. And the thing that I love about AutoCAD, and most people like about AutoCAD, is that you can type commands. So you will do this when everybody's up to speed with AutoCAD installing the software. So you can type circle, you can type rectangle. So you don't have to go and click all over the place. They want you to minimize the amount of clicks, and then you can just basically type a lot of things: save, circle, export, things like that. The status bar is where you're gonna have your grids, your snap tools, your perpendicular tools, all the things to help you model and navigate.